Here is our product examination project. We are group 5 with Matthew, Joshua, John, and Spencer. The product we are going to examine is a skateboard. The skateboard deck is made through the process of glue laminate wood. 7 sheets of maple wood are glued together and pressed with the force of 40 tons into a mold to give the skateboard its concave shape. After 3 hours, it is dried and holes are drilled into the deck to hold the bolts. Then it is cut into its shape using a cutting blade. It is then drum sanded and buffered to smooth out the edges. The wheels are made of polyurethane, which are placed into a mold and baked at 240 degrees Fahrenheit, which allows the bubbles to rise and leave no weak spots. The trucks are made of multiple components such as the hanger and base plate, axle, bushings, washers and speed rings, kingpin, and kingpin nut. The hanger and base plate are made of aluminum alloy and are made through the same process of either die casting or gravity casting. The axle is made of steel and is made through the cold forging process. The threads are formed by rolling. This part is placed into the hanger's mold during casting. The bushings are made of polyurethane and are created through injection molding. On top of the bushings are steel washers, which are made through the stamping process using a power press. Similar to the washers, the speed ring is made through the same process and is smaller, with its purpose to separate the bearings from the chucks. Finally, the kingpin and kingpin nut are both made of steel. The kingpin's thread is created through the rolling process and has a zinc coating through the hot dip galvanization process. The kingpin nut is cold forged and tapped to create its threading. It is zinc coated through the hot dip galvanization process as well.
Next up will be the bearing balls. Bearing balls are usually made of ISI 52-100 steel, and there's a sequence of different processes in order to create these. So first it's cut from a steel rod, and then is cold forged into a rough ball. So as you can see right here, it has almost an equator, and then on the ends, it has extra material. So to get this off, it is flashed or also known as filing down to remove the excess in order to get a rough ball shape. And then it is heat treated, and then it is ground and then polished in order to have less friction. Next will be the bearing inner and the outer race. As you can see, that is circled. So it starts off as tube stock, and then on the inside of the outer race and the outside of the inner race, it is bored paths for the balls, and then it is heat treated and then tempered, and then it is grinded to the final dimensions, and then is honed for a surface finish, which is polishing in order to have less surface friction in order for the bearing to be as smooth as possible.
Next up is the bearing shield component. Its purpose is to keep dust and debris out and then internal components in. Our shield is made out of stainless steel as it is magnetic. I could not further disassemble the bearing, so if I were to set up a manufacturing process, I would use stamping. It would allow for inner and outer diameter cuts as well as bending and chamfering. The last component is grip tape. Grip tape, I believe, starts as extruded sheets of plastic, and then adhesive is applied to both sides, and then a granular substance is added to the top for grip.
Inside the bearing, we have the bearing retainer, which is this nylon piece. The nylon pellets are heated up and then injection molded into a mold to form this kind of complex shape. We know this because it has these tight tolerances that need to fit the bearings properly to allow them to. Then we have the nylon insert locking nut. The nut itself is cold forged, made out of stainless steel. The cold forging process allows them to put on the threads and give it shape. It's then zinc coated with a hot dip galvanization process, which creates corrosion resistance. And then the nylon insert is heated up again and then injected into a cavity to help prevent against loosening with vibration. And finally, the countersink flathead bolt. This is a stainless steel 1032 bolt. The threads are made by rolling, which is the most efficient, accurate, cost-effective for large runs. Countersink feature is added afterwards through cold forming, which accurately places the countersink relative to the threads. And then it is zinc coated using the same hot dip galvanization process.